Welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield, and we're going straight back into our IGCSE past paper review series for my UF and GE. Functions question. Let's get going. So the function is 3x minus 5 all over 4. Find f of minus 7. That means replace x in my function with negative 7 and see what happens. So it becomes 3 times minus 7 minus 5 over 4. So 3 times negative 7, negative 14, negative 21, take away 5. Negative 21 take away 5 is minus 26 over 4. Negative 26 over 4. Negative 6.5. There, 1 mark. Substitution, pretty easy. Express the inverse function in the form f minus 1x equals. So, if we consider the function as y equals 3x minus 5 over 4, to find the inverse, we can do that by simply making x the subject of this. Okay? Just rearranging until it's x equals instead of y equals. So, first, times both sides by 4. 4y equals 3x minus 5. Add 5 to both sides. 4y plus 5 equals 3x. And then divide both sides by 3. So I end up with 4y plus 5 over 3 equals x. Sorry, over 3. It's supposed to be a fraction sign, excuse me. So, now that that's been rearranged, swap around x and y, and then we have our inverse function. Y equals 4x plus 5 over 3. Okay, now instead of y, I use this label, f minus 1 of x, to just indicate that it's an inverse. That is what that sign represents. Okay, so that is 4x plus 5 over 3. And look at that, we're halfway through the question already. A and B done. The function g is such that g of x is the square root of 19 minus x. Find fg of 3. Okay, so what I need to do here is substitute 3 first into the g function to get a result. And the result of that will be substituted into the f function. This is called a composite function, or as I like to call it, functionception, function within a function. So 3 into there, so it becomes the root of 19 minus 3, that's the square root of 16. Let's take that to be equal to 4 for now, okay? So we take 4, we're going to put it into f. f of 4 is 3 times 4 minus 5 over 4. You might be asking, where does that come from, sir? The f function's up here, yeah? 3x minus 5 over 4. And it's 3x, where x is 4, minus 5 over 4. Okay, so that becomes 12 minus 5, 7 over 4. 7 over 4. Or 1.75, okay? 1.75. This is probably going to be sufficient for this part of this GCSE paper. I know what you're telling me. I know what you're saying right now. You're saying the square root of 16, it could be 4, but it also could be negative 4. And you'd be right. I think, though, we're going to take this square root as a positive just for this question. Does it make sense? You be the judge. Now, this last little section. Which values of x cannot be included in any domain of G? Which values of x cannot be included in any domain of G? Now remember what we said when we covered this at school. The domain means the inputs, the list of all the possible inputs that could go into the G function. Okay? Let's think about what we've got here. We've got a square root. A square root. We can only find square roots, assuming real numbers, when the roots are positive, right? If this square root was positive, then we'd be able to find it. I mean, you could say the square root of 0 is 0 as well. So I suppose if x was 19, 19 take away 19 is 0, root 0 is 0, that still works. But if x was any bigger than 19, then this square root would become negative. And at that point, it wouldn't work anymore. You can't find the square root of a negative number yet. Anyway, so because of that fact, I say if x is bigger than 19 for my inputs of x, it cannot be included. All of the values, every value of x that's bigger than 19 cannot be included in the inputs because it means that the g function does not work anymore. I hope that makes sense. That is another IGCSE question. A page of functions marks, 7 marks this, and none of them particularly too invasive or obtuse, assuming that you understand how to find the inverse of a function and how to work with finding values in composite functions too. I hope that helps you. I wish you all the best. Yeah, take care of yourself, and I will talk to you very soon.